Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. Today we are going to take the lecture number 31, and we started yesterday the new topic, that is work, energy and power. Yesterday we talked about the work, and I given you the concept of work. Today we are going to discuss the second scenario, and that is energy. In my view, for the students of O level or any other category, the understanding of this energy is of extreme importance. So let us talk about the energy. Yesterday I told you that these physical quantities are related with each other. Today you will learn that how work is related to energy. So let us start, ladies and gentlemen, the concept of energy. First of all, we have to define the energy. The energy of an object can be defined as the ability of an object to do work. Ladies and gentlemen, notice the word work. The ability of an object to do work is called energy. Nobody will be able to do any work without the supply of energy. Neither human beings nor machines can do any sort of work without the supply of energy. Remember, ladies and gentlemen, that word work was there in the definition of energy. So the unit, the SI unit of energy is also joule. Yes, remember this, that both work and energy has the same unit of SI unit, and that is of joule. I also wrote here that without the supply of energy, neither human nor machine can do work. So we define the energy, but there are many other types of energy available around us. You must understand those types of energy. So the types of energy is our next topic, and in those type we are having the first one is chemical energy. Chemical energy is stored inside the oil, in wood, in coal, and electric cell, which are also known as dry cell, and food. These are called chemical energy. When vibrant, then they are given energy to different bodies, such as food is given energy to our body, and that energy in the foods are stored in the form of chemical energy. Also, energy in the explosives are also stored in the form of chemical energy. Remember these things. What is also having energy when we are burning, they are producing heat energy. Similarly, coal is also having chemical energy when we burn it. So something happened to that chemical energy and it do a useful work. Similarly, dry cell, if we are turning on radio transistors, etc., we need for that the chemical energy which is stored in the form of cells. Similarly, we are having nuclear energy, and nuclear energy is stored inside the nucleus, And by any means, if we are taking out that energy from the nucleus, we can utilize it for different purposes. This type of energy is stored in the atomic bombs and nuclear reactors. Now, radiant energy is also a form of energy. In electromagnetic spectrum, there are different types of radiant energy available. In electromagnetic spectrum, if we are observing, so there are different type of energies in the form of visible light. Light is also a form of energy. Radio waves, they are the carrier of energy, so it is also a type of energy. For example, they are carrying sounds from transmitter to the receiver. So radio waves are also a type of energy. There is infrared radiation, and this infrared radiation is used for small distance communication, such as in remote control of the television set. Ultraviolet radiation is also used for cutting purpose and for different types of happenings in our daily lives. X-rays are also electromagnetic radiation similar to the light, but they are of very short wavelength. And similarly, gamma rays are, these are all the types of radiant energy. At specific time of this course, we will discuss these types of energy at appropriate time, but for the time being, you should know that there are different types of energy in which there is radiant energy as well. The most important one which we are using in our daily lives is the electrical energy. There is magnetic energy as well, but because electric and magnetic energy are so closely related to each other, now the physics has given it one name, that is called electromagnetic radiation or electromagnetic energy. What is electrical energy? The energy associated with the current. What is current? The flow of electron. So when there is a flow of electron, it means energy is required to transfer electron from one location to another location. So the energy associated with current in electrical appliances such as heater, electric kettle, etc. So electrical energy is also very useful form of energy. Because current is producing magnetic field around it, so we are generally talking electrical energy, but magnetic energy is also in the bicycle dynamo. We are using that type of energy. We will discuss that in greater detail when it comes to the electricity and magnetism portion of this physics course. There is another type of energy which is called internal energy. An energy possessed by an atom or molecule is called internal energy. Uh, Energy possessed by atom and molecules in a matter is called internal energy. Now, ladies and gentlemen, one very important type of energy is not mentioned here because that is the topic of our interest. So, I given that energy another name, that is called mechanical energy. Uh, Mechanical energy can be further subdivided into two part. One is called kinetic energy and the second one is called the potential energy. So, ladies and gentlemen, kinetic energy and potential energy, we will study that in greater detail because it is included in the CIE exam. So, we have to discuss it here. Now, wherever there is a motion, there will be kinetic energy. Wherever there is a motion, there will be kinetic energy. The energy possessed by the energy possessed by a body by virtue of its motion is called kinetic energy. Mathematically, kinetic energy can be given as E, and you have to write K as a subscript, is equal to 1 over 2 mv square, where m is the mass of object and v is the velocity of object. By seeing this equation, we can conclude that if there are two bodies of same masses and of different velocities, the masses are the same but velocity of the two different objects are different. So, ladies and gentlemen, the mass which is having high velocity will have more energy. For example, there is a bullet of the same mass, but one bullet is moving fast and the second bullet is moving slowly. So, the bullet which is moving fast can penetrate further in a wooden block. Then the bullet which is having in a slow motion. So you can see that either mass or velocity will play the role of energy. If I'm taking it in another sense, so let us talk that there are two different masses, but the velocities are the same. They are moving with the same velocities, but they are having different masses. One is smaller and the other is larger. So, ladies and gentlemen, the mass which is having larger mass, that will possess more energy. So, by seeing this equation, we can see that potential energy is kinetic energy is the energy by virtue of its motion. When there is a motion, there will be kinetic energy. Let me give you one example. This question is clicking my mind that when electron is moving around the nucleus, when electron is moving around the nucleus, we are saying that this electron is having potential energy, not the kinetic energy. Why it is so? I am leaving the answer of this question on you people, and if by any means you are not being able, then I will answer it. Search uh, the internet for it, ask from anyone and try to understand the concept. If you not understood the question, repeat it again, revise the video and you can do it. Okay, so there is a question given on this on page number 84, and that is work example 6.3. Work example, and that is, ladies and gentlemen, these examples are playing very important role when you want to apply practically the knowledge of that topic you gained. So here a bullet of mass 0.02 kilogram. Mass is 0.02 kilogram. I should mention here that the mass must be in kilogram, and the velocity is in meter per second. So the question is further saying travels at a speed of 1200 meter per second. So it means that 1200 meter per second is the speed. Calculate the kinetic energy. So we have to calculate the kinetic energy. As kinetic energy is equal to 1 over 2 mv square. So we have to put the value 0.02 and 1200 square, and when we calculate it, 14,400 joule of energy is needed for this bullet to travel with this speed of this mass. Okay, that's it, ladies and gentlemen, about the first form of mechanical energy, and that was kinetic energy, the energy possessed by a body a virtue of its motion. Now we are turning our focus to potential energy, and we are saying the energy possessed by a body by virtue of its position or condition. Yes, these both words should be used because potential energy not only depends on the position but also the configuration or orientation or condition. Mathematically, we can write this EP is equal to mgh. Ladies and gentlemen, if there is a height, then there must be a potential energy. If we are taking Earth as a reference point, and there is a block on the Earth, and we are raising that, we are applying a force in upward direction, and we are raising it to a height h. So it means the potential energy with respect to ground, if we are taking the reference point as a ground, will be different at the height h. So we are applying a force in upward direction, and there will be a weight of the object that is called W, and W is equal to mg. So ladies and gentlemen, if we are raising this block to a height h, then there will be a kinetic energy equal to Fh. And that in this case the force is Wh, and then we can see W is equal to mgh. So mathematically we can write that this potential energy is equal to mgh, where m is the mass, g is the gravitational pull, uh, gravitational energy, and h is the height. One thing I must mention here, and that is that if there is a table on which we are putting a block of wood, this is very important concept, please pay attention. So if we are raising it to a height h, so the potential energy of this block with respect to the top of the table will be different from the potential energy with respect to the ground level. So keep in mind, wherever you are taking the reference point, from that point you have to measure the uh, height. For example, in this case, we have to measure the height with respect to the tabletop from the top of the table till the point where the block is raised. Ladies and gentlemen, when we are raising the block, we have to do work on the object. We have to utilize our chemical energy stored in our body to raise this to a point. If there is no energy, I told you at the beginning, if there is no supply of energy, neither human or machine can do work. Keep this in mind. So let me tell you, ladies and gentlemen, that we human being, when raising the block of that wood, must possess an energy to raise it to the height, and that energy is stored inside that object is a gravitational potential energy. Is a gravitational potential energy. Work has to be done on the object, and that work done will be stored inside the object as a gravitational potential energy. One thing. The second thing is that if we are leaving that block of wood, so then it is falling down, and that potential energy is converted into kinetic energy, because there is a potential energy inside it and it is moving. So a question arises in the mind that there is no energy and still the block is moving down. How it is possible? Because the teacher told us that energy is required. Yes, energy is required. Still I am on the belief where that energy comes from. It is stored in that body in the form of potential energy. When you release that object, the potential energy is converted into kinetic energy. And when we are driving a stake inside the, for example, this is a stake and we are driving it in the ground, so work has to be done by that. If we are releasing this and it is inserting itself in the ground, so this stake must do work to be inserted inside this ground. So work done by the system and work done on the system are two totally different concepts. Keep this in mind. We are doing the work, so work is done on this system. And if we are leaving, the body is work on the ground. So the work is done by the system on the ground. Remember, these two concepts are very important. It will help you somewhere in your physics career. So keep these things in mind. So potential energy is equal to mgh, and ladies and gentlemen, there is a work example to understand the concept of this work example is given. A package of 5 kilogram is lifted vertically through a distance 10 meter. Here I have to write that a object of mass of the package M is equal to 5 kilogram, and then we have the height is 10 meter. So they are asking that taking the acceleration due to gravity to be 10 meter per second, where g is 10 meter per second square, acceleration due to gravity. So now they want what is the gravitational potential energy gained by the package. So we are writing here gravitational potential energy. And ladies and gentlemen, if you are uh, understanding and memorizing these formulae, which is here, by seeing the data directly, it will come to your mind that we know that potential energy is mgh, and if we are putting the values of m is a 5, g is 10, and h is 10, so it will be 500 joule. And you must understand that if a 5 kilogram of mass is there and we are raising it to a 10 meter without any acceleration, no acceleration, quickly, slowly we are taking it to a 10 meter height, then the potential energy near the surface of the earth will be constant, uniform. So we are putting these values, and in this case the potential energy will be like this. Okay, ladies and gentlemen, let us talk about the law of conservation of energy. In this topic, we will not only cover the portion conversion of energy, but also the conservation of energy. What does it mean? Let us first define it. Law of conservation of energy is saying that energy can neither be created nor destroyed, but it can be converted from one form to another form, and the total energy will remain conserved or remain the same. Ladies and gentlemen, this is a very deep topic. Many students at this level are thinking that what is it? Energy can neither be created. We cannot create energy. So first question is from where that energy is coming. This energy is a God gifted thing. God is giving this. We cannot create energy. Yes, it is true. But the student then thinking that we are saying that ABC dam is generating, creating this much energy. That is the capacity of this much energy of the dam. So then it is confusing that again they are saying energy being created. No, they are not created the energy. The energy is converted. In the dam there is water, and that water is coming from a height downward. There are roller turbines which they are rolling it. There are shaft, and that shaft is moving like this when water is coming. And before this topic, I told you when there is a height, there is a potential energy. So when that water is falling down from a height, the water is possessing potential energy, and that potential energy running those turbines, moving those turbines, and those turbines are connected with an internal system which are used to create the energy. So energy has not been created, ladies and gentlemen. It is converted from that potential energy stored in the water at height, but we have not created. So that is the main example that energy can neither be created nor destroyed. We cannot destroy it. In this particular case, we have not destroyed the potential energy stored inside the water, because the people are asking that when that water is falling down, it means that the potential energy is wasted. No, it is not wasted. If you are a clever person, your country is having clever scientists, then they are thinking that we can utilize this energy to do some useful work, and they are designing the turbines, and as a result that useful potential energy is converted into kinetic energy. So that water is a god gifted energy to the human being. A human being has not created that water, the energy stored inside the water. So in this case, you have to learn that energy can neither be created nor destroyed. It can be converted from one form to another form, and that conversion and conservation of energy is a compact form of the law of conservation of energy. Ladies and gentlemen, there are many other examples of the law of conservation of energy, but as we are running out of time, so we will stop it here, and tomorrow we will discuss the more useful concept of this energy, how energy can be converted from one form to another form. We will discuss every topic in greater detail, so don't miss the tomorrow's lecture. If you haven't subscribed my channel, subscribe it so you will be in contact with me, and whenever I upload a video, you will be the first person to be informed when I upload the video if you press the bell icon. Thank you very much for watching. Have a nice time. Allah Hafiz.